Today we're going to dive into something both fascinating and controversial, nicotine. Now, most people immediately associate nicotine with smoking, addiction, or health risks. And that's true, but what's rarely discussed is how nicotine actually works in the brain, specifically how it binds to certain receptors, alters neurotransmitter release, and in some contexts, sharpens attention and focus. My goal isn't to encourage its use, but to unpack the neuroscience so you can understand exactly what's happening when nicotine enters the system and why it can have such a powerful effect on mental performance. Nicotine binds to acetylcholine receptors in the brain, and this interaction is what gives rise to many of its powerful effects on focus, attention, and cognition. To understand this process, it is important to first know what acetylcholine itself does. Acetylcholine is one of the key neurotransmitters involved in learning, memory, and attention. When you are highly alert, paying attention to details, or trying to focus on a specific task, acetylcholine activity in the brain increases. It essentially acts like a spotlight, filtering out irrelevant information and enhancing your ability to process the most important sensory input. The brain's natural acetylcholine system is finely tuned, and nicotine, when introduced, acts almost like a chemical mimic. It binds to the same receptors that acetylcholine normally binds to, called nicotinic acetylcholine receptors. These receptors are distributed across several important brain regions, including the cortex, hippocampus, and prefrontal areas, all of which are directly involved in decision making, learning, and memory. When nicotine binds to these receptors, it doesn't just mimic acetylcholine, it often produces a stronger and longer-lasting effect. This leads to increased firing of neurons and the release of other neurotransmitters, such as dopamine, norepinephrine, and serotonin. Dopamine is especially significant because it is tied to reward and motivation. This is one reason why people feel more motivated or find it easier to sustain attention when using nicotine. It enhances the signaling in circuits of the brain that are already primed for focus, effectively making tasks feel more engaging and less effortful. Norepinephrine, another neurotransmitter released through this pathway, also plays a role in arousal and alertness, giving an additional boost to cognitive performance. In practical terms, when nicotine enters the body, it quickly crosses the blood-brain barrier and begins binding to these receptors within seconds. The result is a heightened state of alertness and improved capacity to concentrate on tasks. For instance, someone who is studying, solving complex problems, or trying to sustain long periods of mental work may experience a noticeable sharpening of attention. This is not accidental. It is the outcome of nicotine directly enhancing the circuits that control focus. Research has even shown that in certain controlled doses, nicotine can temporarily improve working memory and reaction time, which explains why it has been studied in the context of neurodegenerative diseases like Alzheimer's, where acetylcholine systems are impaired. Another layer of this interaction is receptor desensitization. Nicotine binding to acetylcholine receptors does not simply turn them on indefinitely. Instead, it activates them strongly for a short period and then leaves them less responsive afterward. This creates a cycle where the brain begins to expect more nicotine to achieve the same effect. At a neurobiological level, this is what underlies tolerance and dependence, but in the immediate moment, it is what drives the initial cognitive boost people associate with nicotine use. That first sharp effect of focus comes from the rapid activation of these receptors and the cascade of neurotransmitter release that follows. It's also important to note that the distribution of nicotinic acetylcholine receptors is not uniform throughout the brain. Some clusters are more concentrated in areas tied to reward and motivation, while others are more directly connected to attention and learning. This means nicotine doesn't just act like a simple switch for focus. It modulates multiple systems at once, amplifying the brain's natural ability to prioritize information and sustain mental effort. This is why users often describe a dual effect. Not only does their attention sharpen, but the task at hand feels more rewarding and less fatiguing. What fascinates neuroscientists is how nicotine hijacks an existing system that evolved to help humans survive by focusing on relevant stimuli, whether it's tracking movement in the environment, learning new skills, or paying attention in social situations. Acetylcholine was designed to be a natural modulator of focus and learning, and nicotine, by binding to those same receptors, artificially boosts those capacities in the short term. It's not creating a new pathway, but enhancing a pathway the brain already relies on heavily for adaptive behavior. This is the essence of why nicotine can feel so powerful and why its effects on focus are immediate and noticeable. Nicotine's ability to increase dopamine is central to why it has such a profound effect on motivation, reward, and reinforcement. Dopamine is often misunderstood as simply the pleasure chemical, but in reality, it is more accurately described as the neurotransmitter of motivation, drive, and the anticipation of rewards. It is what pushes us to take action and sustains our willingness to pursue goals, whether those goals are immediate, like finishing a task, or long-term, like building a career. When nicotine enters the brain, it binds to nicotinic acetylcholine receptors, and this action stimulates the release of dopamine in key regions such as the nucleus accumbens and the prefrontal cortex. These brain regions are crucial in determining how rewarding something feels and whether we are motivated to repeat it. By amplifying dopamine release, nicotine increases not only the sense of reward, but also the energy and drive to continue focusing on tasks. The dopamine system is designed to respond to natural rewards like food, social interaction, or achieving a meaningful accomplishment. However, nicotine artificially elevates dopamine levels beyond what would typically be triggered by natural stimuli. This is part of why nicotine has such a strong reinforcing effect. The brain interprets the surge in dopamine as a signal that something highly valuable has just occurred, and it motivates the person to seek that experience again. Unlike natural rewards, which often come with a delay or require effort, nicotine delivers its dopamine, boosting effect rapidly within seconds of entering the body. This speed strengthens the association between the act of consuming nicotine and the reward it produces, essentially training the brain to link the two very tightly. In terms of focus and cognition, dopamine plays a dual role. On one hand, it increases motivation, making tasks feel more engaging and worthwhile. On the other hand, it modulates circuits in the prefrontal cortex that are responsible for executive functions like working memory, planning, and sustained attention. When dopamine is elevated in these areas, it enhances the ability to resist distractions and remain locked in on a particular goal or activity. This is why nicotine can feel like it makes boring tasks more interesting or helps sustain long periods of mental effort without the same level of fatigue or frustration. The increase in dopamine shifts the brain's cost-benefit analysis, making the effort required to focus feel less costly and the reward more immediate. Another dimension of nicotine's impact on dopamine is its ability to influence the timing and pattern of dopamine release. Natural rewards typically create bursts of dopamine that are tied to specific outcomes, while nicotine produces a more sustained increase, elevating baseline levels of dopamine activity. This persistent elevation creates a general sense of heightened motivation and drive, not just toward one task, but across different domains of behavior. For example, someone using nicotine may feel more motivated not only to focus on studying, but also to engage in conversations, pursue creative projects, or complete physical tasks. This broad effect stems from the way dopamine regulates the brain's salience system, which determines what is important and worth paying attention to at any given moment. Nicotine essentially increases the salience of whatever is in front of you, making it feel more meaningful and rewarding to engage with. However, the repeated and artificial elevation of dopamine does not come without consequences. Over time, the brain adapts by reducing its sensitivity to dopamine, a process known as downregulation. This means that in the absence of nicotine, natural rewards may feel less motivating or less pleasurable than they once did. Someone who has repeatedly used nicotine may find it harder to feel engaged or driven without it, which reinforces the cycle of use. While this adaptation contributes to dependence, it also highlights how powerful nicotine's dopamine boosting effect is compared to natural experiences. Still, in the short term, the increase in dopamine that nicotine produces can sharpen motivation and sustain focus in ways that many people find highly beneficial. It is not just about creating a momentary feeling of pleasure, it is about amplifying the brain's internal drive systems so that tasks that might otherwise feel mundane become more compelling. By stimulating dopamine release in the prefrontal cortex, nicotine supports the kind of sustained attention and effortful control that are necessary for learning, problem solving, and productivity. At the same time, by activating dopamine in the reward circuits, it ensures that the experience feels worthwhile, which is why users often describe nicotine as making work or study sessions feel smoother, more enjoyable, and more productive. Short-term use of nicotine has a very noticeable effect on sharpening attention and focus, and this is one of the main reasons people often report that it helps them concentrate during tasks that demand sustained mental effort. When nicotine enters the brain, it quickly engages nicotinic acetylcholine receptors, leading to a cascade of neurotransmitter release that includes acetylcholine itself, dopamine, norepinephrine, and serotonin. This cocktail of chemical signals works together to enhance vigilance, elevate arousal, and support the executive functions of the prefrontal cortex, the brain region that controls planning, focus, and impulse regulation. The immediate result is a heightened ability to lock in on a task, filter out distractions, and sustain concentration for longer than usual. Unlike stimulants such as caffeine that primarily work by blocking adenosine receptors to reduce fatigue, nicotine directly modulates the brain's attentional networks, giving it a unique profile in terms of cognitive enhancement. One way to understand this sharpening effect is to look at how nicotine impacts the prefrontal cortex and parietal lobes, both of which play key roles in directing attention. Acetylcholine is the brain's natural mechanism for increasing the signal-to-noise ratio, meaning it strengthens the processing of relevant information while dampening irrelevant input. By binding to acetylcholine receptors, nicotine artificially amplifies this mechanism, effectively narrowing the brain's spotlight of attention. For example, when someone is studying, reading, or analyzing information, nicotine enhances the ability to stay focused on the material without being pulled away by external noise or internal distractions like mind wandering. This capacity to selectively tune into important stimuli is one of the hallmarks of nicotine's cognitive enhancing effects in the short term. Norepinephrine also contributes significantly to this sharpening effect. Released from the locus coeruleus, a brainstem nucleus associated with arousal and vigilance, norepinephrine heightens alertness and responsiveness. When nicotine stimulates norepinephrine release, it raises the baseline level of attentional readiness, making the brain more responsive to incoming information and better equipped to sustain high levels of performance. This is why individuals often report feeling more awake, mentally energized, and capable of sustained concentration after nicotine intake. It provides not just a subjective sense of clarity, but measurable improvements in reaction time, working memory, and the ability to filter out irrelevant distractions. Studies have demonstrated that nicotine can improve performance on tasks requiring continuous attention, such as monitoring screens for specific signals or maintaining accuracy in repetitive cognitive exercises. These effects are particularly evident in situations where fatigue or monotony would normally cause a decline in performance. In such contexts, nicotine helps maintain a steady level of focus, reducing lapses in attention and sustaining engagement with the task at hand. Even in more complex problem-solving situations, short-term nicotine use has been shown to facilitate quicker recall of relevant information and greater cognitive flexibility, suggesting that its impact is not just limited to basic attentional processes, but extends into higher-order cognition and, another aspect of this effect is the subjective experience of focus. People using nicotine often describe feeling like tasks become more enjoyable or easier to engage with. This is not just due to dopamine's reward. enhancing effects, but also because the brain's attentional networks are being tuned to prioritize the task, making it feel more immersive and less effortful. In essence, nicotine reduces the cognitive friction that can make focusing on demanding or uninteresting tasks feel draining. By smoothing the brain's processing of relevant inputs and making tasks feel more rewarding, it creates a synergistic state in which focus is not only sharper but more sustainable. The short-term nature of this effect is critical to emphasize. Because nicotine causes receptor activation followed by desensitization, the heightened attentional state it induces is temporary. Initially, there is a strong surge of clarity, focus, and drive, but as the receptors become less responsive, the effect diminishes. This transient window of enhancement explains why many users feel the need to redose nicotine after a period of time in order to maintain the same level of cognitive performance. Nevertheless, within that window, nicotine provides a potent boost to attention that can make an immediate difference in cognitive tasks. Researchers have even explored nicotine's short-term focus, enhancing effects in populations with attentional deficits, such as individuals with ADHD. Because nicotine boosts acetylcholine and dopamine signaling in areas of the brain that are underactive in ADHD, it has been found to improve attention and reduce impulsivity in the short term, much like stimulant medications do. This demonstrates that nicotine's ability to sharpen focus is not only subjective, but also grounded in its clear neurochemical effects on attention, regulating circuits. The overall picture is that nicotine, in small and short-term doses, provides a rapid enhancement of attention and focus by amplifying the brain's natural neurotransmitter systems that regulate vigilance, reward, and executive control. It narrows attentional focus, sustains engagement with tasks, and makes the process of concentrating feel less effortful, offering a temporary but powerful boost in cognitive performance. Would you like me to expand Keynote 4 into 600 words next, focusing on long-term use, addiction, and health risks? Long-term use of nicotine presents a very different picture compared to the short-term benefits people often report. While the immediate effects may include sharper focus, increased alertness, and enhanced motivation, repeated exposure to nicotine over time fundamentally changes how the brain and body respond to it. One of the most significant risks of long-term use is the development of dependence and addiction. Nicotine is one of the most addictive substances known because of how quickly and powerfully it engages the brain's reward circuits. Each time nicotine is consumed, it releases dopamine in the nucleus accumbens, creating a strong association between the act of using nicotine and the feeling of reward. With repeated use, the brain learns to expect this artificial dopamine surge, and the absence of nicotine begins to feel uncomfortable, leading to cravings and withdrawal symptoms. This cycle drives continued use, making it very difficult for many individuals to stop once they have developed the habit. Another consequence of long-term nicotine use is tolerance. Over time, the nicotinic acetylcholine receptors in the brain become less sensitive due to constant stimulation. The brain attempts to maintain balance by downregulating or desensitizing these receptors, meaning that the same amount of nicotine produces a weaker effect than it once did. As a result, people often find themselves needing higher or more frequent doses of nicotine to achieve the same focus or calming sensation they initially experience. This escalation further strengthens dependence and increases the overall exposure of the body to nicotine and any other harmful compounds that may be present depending on the method of consumption, such as smoking or vaping. Long-term nicotine use also carries health risks beyond the brain. While nicotine itself is not the direct cause of many of the severe diseases associated with smoking, such as cancer, it has systemic effects on the cardiovascular system. Nicotine increases heart rate and blood pressure by stimulating the release of adrenaline, which places added strain on the heart and blood vessels. Over time, this can contribute to an increased risk of hypertension, heart disease, and stroke. For individuals with pre-existing cardiovascular conditions, chronic nicotine use may exacerbate those risks even further. Vaping, often seen as a safer alternative to smoking, still exposes the cardiovascular system to nicotine and can contribute to similar long-term health consequences, even if it eliminates some of the toxic byproducts of burning tobacco. There are also important implications for mental health. While short-term nicotine use can temporarily reduce anxiety and enhance mood through dopamine and serotonin, in release, chronic use often has the opposite effect. As the brain becomes reliant on nicotine to regulate these neurotransmitters, individuals may experience increased anxiety, irritability, or low mood during periods without nicotine. This can create a feedback loop where nicotine is used to relieve the discomfort caused by withdrawal, reinforcing the cycle of dependence. Over time, this dependence can reduce the brain's natural ability to regulate mood, leading to greater difficulty managing stress without nicotine. Cognitive health is another area impacted by long-term use. While short-term nicotine exposure can enhance attention and memory, chronic exposure may impair cognitive flexibility and executive function. This happens because the constant overstimulation of acetylcholine and dopamine systems alters how these networks operate, making them less efficient when nicotine is absent. In other words, the brain may become less capable of sustaining attention, memory, or motivation on its own, leaving the individual dependent on nicotine for normal levels of focus. Some research also suggests that long-term nicotine exposure could increase the risk of cognitive decline in later life, though this remains an area of ongoing investigation. The method of delivery also plays a large role in determining health risks. Smoking introduces thousands of toxic chemicals into the lungs and bloodstream, making it one of the most harmful forms of nicotine consumption. Vaping reduces exposure to many of these toxins but still carries risks, especially when done over many years, as the long-term effects of inhaling vaporized chemicals are not yet fully understood. Nicotine replacement therapies like patches or gum are generally considered safer but still perpetuate the dependence cycle if used long-term without tapering. Regardless of the delivery method, the biological reality of receptor desensitization, tolerance, and dependence remains. Ultimately, long-term nicotine use represents a trade-off where short-term cognitive gains give way to significant physical, mental, and behavioral costs. Dependence, cardiovascular strain, mood instability, and diminished natural cognitive function all accumulate over time, making it clear that nicotine's benefits are not sustainable without consequences. What begins as a tool for sharper focus or increased motivation can evolve into a cycle of reliance that impacts overall health and well-being in profound ways. Understanding the mechanisms by which nicotine impacts the brain and body is essential for making informed decisions about its use. Many people approach nicotine with preconceived notions, often viewing it solely as a harmful substance associated with smoking, or conversely, as a useful tool for boosting focus and productivity. The truth lies in understanding its dual nature. Nicotine has real, measurable effects on brain chemistry that can enhance certain cognitive functions in the short term, but it also carries long-term risks that can undermine health and mental balance. When individuals are equipped with knowledge of how nicotine binds to acetylcholine receptors, triggers neurotransmitter release, and influences systems like dopamine and norepinephrine, they can better weigh the potential benefits against the drawbacks rather than being swayed by marketing, habit, or misconceptions. One of the key reasons understanding these mechanisms matters is the distinction between short-term enhancement and long-term consequences. Short-term nicotine's ability to sharpen attention, elevate mood, and sustain motivation can feel highly beneficial, especially for tasks requiring concentration or mental endurance. Knowing that these effects arise from the activation of acetylcholine receptors and the resulting cascade of neurotransmitter release helps explain why nicotine can create such noticeable changes in performance. But equally important is the recognition that these same mechanisms, when engaged repeatedly over time, lead to tolerance, receptor desensitization, and dependence. This awareness allows people to see that the very systems providing short-term benefits are also the ones that drive long-term costs. Another critical aspect of informed decision-making is recognizing the role of dopamine in creating cycles of reinforcement. Understanding that nicotine artificially elevates dopamine and that this elevation makes behaviors feel rewarding provides insight into why cravings and dependence develop so quickly. Instead of interpreting cravings as a sign of personal weakness, individuals can see them as the predictable result of neurochemical changes. This perspective reduces stigma and empowers people to approach nicotine use with more clarity and strategy. For example, someone who understands the dopamine cycle might choose to limit their use to avoid dependence, or if they are already dependent, they might use structured methods to taper gradually rather than attempting to quit abruptly without preparation. Knowledge of nicotine's cardiovascular and systemic effects is also central to informed decision-making. Nicotine's stimulation of adrenaline and its impact on heart rate and blood pressure may not be immediately felt in the short term, but over years, these small changes accumulate into greater risks for cardiovascular disease. For someone with a family history of heart problems, understanding this mechanism could be the deciding factor in choosing whether to use nicotine or avoid it altogether. Similarly, understanding that different delivery methods, such as smoking, vaping, or patches, carry different health implications helps individuals make choices that align with their goals and values. Someone may decide that while they want to experiment with nicotine's focus, enhancing effects, they would never choose smoking due to the added toxic load, and they might instead consider less harmful alternatives. Mental health is another domain where knowledge of mechanisms provides clarity. Many individuals use nicotine to manage stress, anxiety, or mood fluctuations without realizing that chronic use actually reduces the brain's ability to regulate these states naturally. By understanding that nicotine temporarily boosts dopamine and serotonin, but eventually leads to downregulation and withdrawal-related mood issues, a person can better evaluate whether they are addressing the root cause of their stress or simply masking it with a temporary chemical fix. Informed users can then weigh whether the short-term relief is worth the potential for long-term mood instability. Ultimately, knowledge transforms choice from impulsive or habitual behavior into deliberate action. When people understand the science behind nicotine's impact on the brain and body, they are less likely to be manipulated by cultural narratives, advertising, or the lure of immediate gratification. They can approach nicotine with a balanced view, appreciating its potential to enhance focus while also respecting its capacity to create dependence and harm health. Informed decision-making does not dictate a single correct answer. It allows individuals to decide based on their unique circumstances, goals, and risk tolerance. For some, this may mean avoiding nicotine entirely. For others, it may mean occasional, controlled use with awareness of the risks. For those already dependent, it may mean choosing a structured path toward reduction or cessation.